Okay, so I put a problem up on the on the screen that we should start with, and this is basically just to kind of remember what we were doing yesterday. So if you guys can, take a minute to do whatever part of that problem you can remember, and then we'll go through it here in a minute or two. And then if there are parts of this you don't remember how to do, then that would be a good time to refresh you. But do what you can to start with quickly here. My guess is most of you were able to get the first three pretty quickly because they're set up for power rule right away. So, like 3x to the fourth, you're going to take the 4 times the 3 and then subtract 1 from the power. 2x is a linear, so technically the power rule still works if you want to do power rule because this is 2x to the first. So then you would do 1 times 2, and then when you subtract 1 in the power you get x to the 0. But otherwise, one of the derivative properties is that if you're taking the derivative of kx, the answer is k. And then 8x to the negative third power works identical to the first term, where you multiply power towards the constant in the front and then subtract 1. It can sometimes be easy to forget that the power would become negative 4 instead of negative 2. Now, did anybody get this last term? My guess is there were some like this in the homework, but we didn't do one together in class. I just thought I'd give a chance for somebody to answer if they wanted to. Okay, here's how you have to do this one. So I'm going to start by combining these two terms together, because you've got an x times x to the 1/2 power. And if you are multiplying two of the same terms, you can add their powers. So that would become x to the 3/2, which would become x to the negative 3/2 power, if I write it on the numerator. So this derivative would become minus 3/2 x, and then when I subtract 1, I'd get negative 5/2. So every term up here can be done with the power rule. Okay, how are we on that? Or certainly ask away if one of these terms up here you're not sure why I got the answer I did. Okay. Well, the next topic is one we've done, but I didn't know if you need a refresher. Okay, how do I get out there? If I were to draw, like a random curve, and if I want to demonstrate or show the slope at any certain location, then I could draw a tangent line which mimics the slope at that location. And that's the best I can do for drawing a line. It's actually really hard to draw straight lines on this tablet. So a tangent line, just a refresher, is a line that touches at that location, touches at that point on the function, and shows the slope at that same location. So you are going to be answering some questions about tangent lines now that we can find derivatives much quicker. So let's do one of the examples together here to start with. What is the slope of the tangent line to y equals 3x squared minus 2x at x equals 3? I am pretty positive I only get text right during the middle of class. So, what, who should we start with? Jessica? Let's start with Jessica. What should we do to start this problem? And I can guide you if you want some help. You bet. Okay, so over here the tangent line shows the slope at a location. Do you remember what we're supposed to do to find slopes of lines? Okay, that's correct. That is definitely the slow way of doing it. So yesterday we learned the power rule, which is a quicker way of finding derivatives. But what you answered was correct. So the derivative is how you find slopes. So the power rule for this one would be 2 times 3, subtract 1 from the power, which would be to the first, and then minus the derivative of kx is just k. So that would be my derivative. Okay, good job, Jessica. Caitlin, what would I do next? So this equation right here tells us how to find the slopes everywhere on this pink line. Okay, perfect. Which equation do I plug it into? Okay, so y prime. So I'm going to plug 3 into y prime. That's a terrible way of writing it, but that's... So then we would have 18 minus 2, which is 16. Mackenzie, did I answer the question, or is there more I'm supposed to do? Oh, that's not a bad thought. So this one actually doesn't have a label. If I wanted to label it, I would just say 16 units up, compared to 1 unit over, but there's no label. What does this number stand for? I guess that's kind of what I'm asking. Do you remember what? Oh, go ahead. How about this one I'm certain? Yeah, I mean, yes. How about that equation I just circled? Do you remember what that stands for? It is. So the derivative stands for the slope of the original function at any x value. The 16 that I have circled right here is the slope of y at x equals 3, because I plugged 3 in. So what was I trying to answer from the very beginning? Okay, is this the answer, or is there something more we should do? I'm only asking this. I'm not trying to, like, if you're confused on it, I'm not trying to, like, add to it. A large problem that a lot of people have when they start doing problems in calc is they're not sure, like, they're not sure when to stop. Okay. Okay, should we call them? Do you want me to kind of call somebody else to see if they have it? I could do that. Julia? Julia, do you think we're supposed to do something more? Or... I realize you have a lot of teachers that try to lead you guys on, ask questions to make you think that there's more to do. I'm purposely trying to ask questions like this so that you guys, this is what you should be asking yourself. Okay? So this is the answer, and this is done. The slope of the tangent line shows the slope at that location. So when this question says, what is the slope of the tangent line? That is just saying, what is the slope of the function at x equals 3? And then the derivative is the slope of the function at x equals 3. So this is the answer, and this is done. No, I'm not trying to, like, I'm not trying to pull reverse psychology or anything either. I'm trying to get you guys to learn how to ask questions of yourself. So let's do a different example then. Because a lot of times the wording of what's being asked absolutely determines what you're trying to do. And you guys are going to pretty much see all the different variations of everything. Okay, now, I don't have a picture, and I don't actually even need to know what the picture looks like. I mean, some people I know like to visualize things. We don't actually need to know it. Connor, do you think you could help me start? How should I start this? I've got a function, and I've got an x value, and I'm trying to find the equation of the tangent line. Okay, so find the derivative. Okay, so the derivative would be 4 minus 2x. Okay, excellent job. Jack, any thoughts as to where to go from here? Where? But you're correct. Okay, so into the derivative. Okay, so f prime of 1 would be 4 minus 2 times 1, which would be 2. Okay? Kelly, think you could guide me from here? Or am I done? That's a good thought. I guess I didn't even put that one together. So if this said what is the equation of the derivative, then we would have stopped. So that's a good thought. The tangent line is an actual line, like it's a straight line that it's kind of imaginary, but it's a straight line that bumps up next to the graph at that spot. So we're actually looking for the equation of a straight line. I guess that one is a straight line too. But the actual tangent line equation. I don't know if I want to call anybody for this one. Does anybody remember what two things we need to write the equation of a tangent line? We need two things to write the... Nice. We need a slope and we need a point. We just found the slope. So f prime of 1 tells me that this is my slope at x equals 1. Okay, so slope is 2. I have a point. I don't have a point in the problem, but I do have half of a point because I was told the x value. So, Matthew, how do I find the other half of the point? Good. Come on, there we go. So I'm going to find f of 1, and that would be 4 times 1 minus 1 squared, which is 3. And so this tells me I have the point 1, 3. And then I'm going to write my answer in slope-intercept form. Excuse me, point-slope form. You can write it in slope-intercept if you want. Slope-intercept is just extra steps, and so I'd recommend not. So point-slope form is just writing your information in and then leaving it like that. Now, these are going to be the two main kind of questions you're going to run into for tangent lines. Sometimes you are going to be asked to find the slope of the tangent line. Sometimes you're going to be asked to find the equation of the tangent line. They definitely involve similar work and similar steps, but your answers are obviously very different. So you just have to make sure to read the wording of what's being asked of you. And I know in most previous math classes, a lot of times the story problems, you could have pretty much ignored most of the wording to be able to do the problem. This isn't even a story problem, but like in calc, the wording is usually pretty important. Okay, I don't know. I didn't want to take up like way too much time doing tangent line stuff. Do you guys want me to just make up another problem for you to try, or do you want me to move on? Either one's fine. Maybe, how about this? Type it in the chat. Then you don't have to worry about speaking up in an awkward classroom. I know everybody hates that. Nobody has any thoughts? Wow, you guys, thank you, Caitlin. At least you gave me a thought. You guys, you're just very blah today. Okay, well, the last part, theoretically, it'll probably scare you by looking at it, but it's actually super easy. So, you can't always use the power rule to do derivatives. And that's because not every derivative is written as a polynomial or with powers. So there are some other derivatives that we're going to start working on now. So the first one is the derivative of sine of x. Second one, cosine of x. Now here's what I'd recommend for you guys. And I don't know if I don't even know if I've said it or not yet. I probably started talking to you about start keeping note cards, like cheat sheets to yourself, and organize them by unit. Each unit is going to start having more and more formulas for you. And it's honestly really hard to remember them, especially if you're going really fast pace. So I would start keeping a note card for yourself for each unit, and then write formulas like this on it. Two more. I've got derivative of e to the x, which is awesome because it's the same thing. Okay. The one that always really confuses me is e to the x. And that's because the slope at any spot on e to the x is the same as e to the x. So like the slope at x equals 2 is e squared. And the point at x equals 2 is e squared. Okay, so these four are just kind of like memorize them. Okay? You know, whether that's good or bad, that's just what we got to do. And I thought I would just put up some problems for us to try to show you how to use them. Oh God, that was bad. So yesterday I told you that I had already taught you part of today's, because I did. It was about derivatives of polynomials. So we're actually done after these couple examples. And I've covered all the material we need to. A lot of you really need to catch up. Some of you are doing great on the homework. Some of you are absolutely doing great. So that is one example that we're going to do. Okay, why don't you guys take a minute, see if you can figure out those answers.
I was gonna grab this, so I banged my head on the fridge handle.
Dude, I'm teaching. You're in the camera. Put some clothes on. Quit taking my pop.
Yeah, I'm gonna bang my head on the handle.
Haley, do you think you can help us out with the top one? And I can help you along with it if you want some help too. Wait. Which one are we talking about here? Yep. Let's start with the first term. What's the derivative of 4 sine x? Because this minus sign in the middle means that we've got multiple terms, and so we can treat them separate. So what would be the derivative of 4 sine x? I didn't know if you were trying to ask me for help or if you were just answering. Absolutely perfect. So the multiplier in the front of the 4 will not affect your derivative. So basically a multiplier in the front is automatically going to be the multiplier on the derivative, and then you just do the derivative of sine of x on its own. And that'll work the same for all of these down here. So yes, okay, so what would be the last one then? What's the derivative of 1/3 cosine of x? Yep. That's it. And so this changes to a plus in the middle because the derivative of cosine is negative sine. So, no, nice job. So trig, I know a lot of you really hate trig. I'm telling you that derivatives of trig are really easy because you don't do anything with them. You don't have to like go to the unit circle. You don't have to, that's their derivative. And all this derivative is saying is what is the slope of the original function at that spot. And I know it seems strange. Sine and cosine are already like basically clones of each other. They're just shifted. And now when you look at their slopes are kind of clones, just shifted. Okay, good. Good. How about or does anybody want me to explain anything on the top one there? All 6. Yeah. So the reason that we wait on the other 4 is because tomorrow we're going to learn something called the quotient rule, which is how you figure out the other 4 trig derivatives. Yeah, so you do need to know all 6, and that's why I definitely recommend like a note card, because there's just, then the other 4 are not easy to remember. These 2 are easy. The other 4 aren't. Yeah. Who should we go with? Was it gone? I don't know. Was it gone? Alyssa? Alyssa, do you think you could help me with the bottom one? Perfect. Yep. -2. And then derivative of e to the x is e to the x. You're right. It's identical. How about the second one? Yep. 5 times 1 over x. I'll just write this first. But what you said is perfect. I'm guessing most people would write 5 over x first because it's positive, and then write -2 e to the x second, but it really doesn't matter. Good. So the key part here is that you guys realize that the multipliers in the front are not going to affect the derivative. I know a lot of people usually get kind of thrown off or scared when they see, like maybe this might be something goofy like pi, right? But that's still just a number. It's still just a multiplier. So if you have a number multiplier on the front, it doesn't do anything to the derivative. All right, that's all I got for today. You guys, your brain is probably super refreshed after previous days of going like at least an hour. On the main calc page for Schoology, I put up a weekly calendar. I don't know if I thought that might help you guys. I do have the calendar for the whole trimester in the resources folder, but I bet nobody looks at it. So I'm wondering if it would help if I put the weekly thing up there. So I'll try to do that each week. I'm hoping you notice that I've already said it a couple times. Basically, our test is supposed to be Friday because of all the days that got cut out this trimester. And now that they canceled school on Friday, I can't officially assign it on Friday, but what I can do is assign it on Thursday night and have it done by Monday morning. So that's what I did in Schoology. I will tell you guys on Friday, I don't think I have any meetings or anything on Friday, but I can just be available to answer any kind of questions you guys have Friday if you want. Like, we don't have school, but, I'll be online, and, if you don't come, that's fine. There's no attendance. But I'll just be there to help you if you want, because this class is really difficult when it's rushed and days are chopped off. So I'll be online to help you guys if you want it. I haven't decided what time yet, and honestly, it doesn't matter to me, because I think we have the whole day free, because the whole day is for teachers to prepare for distance learning, and I've already done that. So I don't know. Yeah, I guess I'm done. I'll stay on till 11:15. Help you guys with anything you want help with. I'd recommend you guys work on your homework in Khan Academy. See as much as you can get done. You might even be able to get finished with everything you're supposed to through today.